Hi there, this is an example of solving a two-system linear equation or a system of linear equations with two equations and two unknowns. So here's the problem that I'm going to do. I have 3x plus 2y equals negative 26, and I have 4x minus 5y equals negative 4. Now, systems of linear equations, when I want to solve them using elimination, there are three ways, there's three legal moves that you can make when solving with elimination. The first move is you can swap two rows. This does not change the value of the x or the y in either of these two equations if we move the rows around. The second thing is I can add the rows. Again, when I add the rows, it does not change the value of those two variables. And then finally, I can make a multiple of the row. An example of this would be, let's say I wanted to multiply one of those equations by 2, like this. This is no different than if I were to multiply both sides of an equation by the same thing. This is the same thing, right? And that doesn't change our value normally, nor does it in this situation. So my whole purpose and goal of doing these things is so that I can get rid of one of these variables so that I can eliminate them. And so what I want to do is I want to look at my two equations and I want to say to myself, is there anything that I could multiply these two equations by that would cause the coefficient of at least one variable to become opposite of each other? Now, on some of the ones that you've probably done, you only had to multiply one equation by that number to make the other number. But if you look at, like, for instance, this 2, if I wanted to make if I wanted to multiply the 2 by something, I couldn't easily get 5. I would have to multiply by a decimal, and it would be more difficult. The thing about elimination is you always want to do smarter, not harder. You want to do the least work possible. So in this case, there's just not an easy number to multiply by. But when you look at the x's, there's nothing you could multiply 3 by to get 4 unless you multiply by a decimal. So there's not really an easy solution here. So now what you need to do is you go, okay, well, let's abandon that idea. Instead, is there a number that I could multiply both of these by that would give me the same thing? And so honestly, if you just take the number 2 and the number 5 and multiply them together, you get 10. 10 is your number. If you multiply 2 by 5, you get 10. If you multiply the negative 5 by 2, you get negative 10. And you want them to be opposite of each other. Similarly, and that's the way I'm going to do it, just FYI. But similarly, you could do 3 times 4 and get 12 and say to yourself, okay, I'm going to multiply this equation by positive 4 to get 12x. And then I'm going to multiply this equation by negative 3 to get negative 12x. And then I would have a 12 and a negative 12, which would add together and make 0. Thus, accomplishing my goal. So I'm going to do what I said first, which is since I've already got my signs going, one's positive, one's negative, I'm just going to multiply by the number that's going to make this 10 here. So if I multiply by 5, I will end up with 10y in the middle. And if I multiply by 2, I will end up with negative 10y in the middle. So that's exactly what I'm going to do. And I'm going to just multiply these and write the new equations. Well, I wrote in that space. No, I'm not. Ha! I'll just write the new equations above it and below it. So 5 times 3 is 15x. 5 plus 2y is plus 10y. And 5 times negative 26 requires me to use a calculator. Although y'all, I guess you get a 4-function calculator, so this is okay. So 5 times, negative 26 is negative 130. Okay, So then the equation below, I'm going to do in another color. That's going to be 2 times 4x, which is 8x. 2 times negative 5y, which is negative 10y. And then 2 times negative 4, which is negative 8. So now I have these two new equations here. This one and this one. The values of x and y have not changed, but these equations are multiples of my original equation. I'm going to mark my original equations. That was the first one. That was the second one. All right, so now what I'm going to do is I'm going to add together the two equations that are in the green boxes. So if I add 15x plus 8x, I get 23x. And if I add 10y plus negative 10y, I get 0y. And if I do negative 130 plus negative 8, I get negative 138. So I've now added my two equations together. This has made my equation number 3. And I'm going to go ahead and solve it for y. So this is going to just go away. So 23x equals negative 138. And negative 138 divided by 23 is negative 6. So now I have effectively solved for x. So now the last step is to take this x equals negative 6 and plug it back into one of these two equations. Doesn't matter which one, I just need it to be original. So if I'm looking at this, there's not really an easier. I probably want to go with this one that has smaller numbers. So I'm gonna substitute it into equation 2, the original equation 2. So instead of x, I'm gonna plug in that negative 6. And then I have minus 5y equals negative 4. So this is going to become negative 24 minus 5y equals negative 4. I'm going to add 24 to both sides, which is going to leave me with negative 5y equals 20. I'm going to divide both of those by negative 5. And y is going to equal negative 4. All right, so my solution is negative 6 comma negative 4. Now, it is always good practice to check your answers, and the way you do that is you stick the values for x and y back into the original two equations and make sure that the statements are true. So that's what I'm going to do here. So my original equation number 1 was 3. And instead of x, I'm going to have negative 6 plus 10. And instead of y, I'm going to have negative 4. And that needs to equal negative, oh, look what I did. Okay, let me back up. I read the wrong equation. So it was 3x, here, let me highlight it for you. It's 3x, which I did do correctly. But then I accidentally read 10y. It's actually 2y, so I'm going to fix it. Sorry about that. We all make mistakes. So 2, and then instead of y, I'm putting in negative 4. And then that should equal negative 26. So we need to make sure that this is true. So negative 18 minus 8 is indeed negative 26. So that's good. And then the next one, I'm subbing in the x again into 4. This is equation 2. So negative 6, that's my x, minus 5 times negative 4. And that should equal negative 4. So I have negative 24 plus 20 equals negative 4. That indeed is true. So I've checked my equation. It all checks out. And this is how you complete a system of linear equations, solving it via elimination when there are two unknowns. Y'all have a great day. Bye.